For those of you that don't know, that this is basically a math class. I see this class as mathematically formalizing common sense. Most of the stuff in here, most of the material, you probably already know, or intuitively know. And this class is basically formalizing it mathematically. So, generally speaking, no big secret here. I don't like the way math classes are normally taught. Too abstract, not enough application. And if it's too abstract, you get done with the semester and it's gone. You know, math classes typically deal with X, Y, and Z and all these other variables. It's like, okay, what does that all mean? Hopefully in this class we'll take care of what things mean as well as the abstract theory behind things. But what are we going to be covering in this class? Functions, sets, relations, proof techniques, propositional and predicate logic, counting, and a variety of other topics. Like I said, it's a lot of stuff you know intuitively. Like if one thing is true and another thing are true, then the combination of the two is true. You know, that's just intuitive logic that, you know, common sense dictates. But how do you express that mathematically? That's what this class is all about. What you need to know. You should take notes. Definitely take notes. You should ask questions. If you don't ask questions, I don't know that you're not getting a concept, and I'll just be moving right along. So if something doesn't sit right or doesn't sink in quite the way it should, ask me. I'll try to reword it or re-express the idea so that it does make sense for you. I do not like flunking people. I will do it if they don't do their work, but I'm here to primarily educate and get things across to you. If it's not getting across to you, ask questions and I will try to re-express it in a way that makes sense to you. I know that not everybody learns the same way. There's three primary ways people learn: visually, verbally, and kinesthetically. This class doesn't lend itself to kinesthetic learning, you know, hands-on type stuff, but I try to express things verbally as well as visually for those who learn in those ways. Communicate with me. If there's a problem, let me know. I work with students. Some students in here I've had before in other classes, and they'll tell you, I'll be happy to work with you. You just have to communicate with me. If I don't know what's going on and you're missing a lot of classes and all that sort of stuff, your grade's going to suffer. Communicate with me. Let me know. You're going to be out of town for sports. Do we have any athletes in the class? No athletes? Oh, got one. You know, I understand sports. A lot of students are on athletic scholarships. Got to take care of the responsibilities that pay the bills. Understand that. I'll work with you. Others go to conferences or have student organization functions and miss class and stuff like that. Let me know. I'll work with you. Make sure you're caught up on the material. I will allow notes on quizzes and tests. I was talking to this gentleman here before class. Getting out into the workforce, there's not a job out there that's not going to allow you to have references, have some sort of reference material. You're not expected to memorize everything. Okay. I'm not going to say open internet and open book and all that, but open notes are allowed on quizzes and tests. If you take notes on a tablet or something like that, print them out before the quiz or the test. So you have them and can use them on the tests. You'll notice I have my cell phone recording the class. I record all my lectures and post them on YouTube, typically within a day or two. Depends on how busy I am. But if you miss a class or you want to review a concept, I will post the link to the YouTube videos in announcements when the videos are uploaded. So you can, if you miss a class, you can review the lecture, that sort of thing. I am, though I am an adjunct professor, which means part-time, I am here most of the time. I have office hours that are listed on the syllabus, but I'm here most days, irregardless. I work on research projects and that sort of thing, so I am available outside of class probably between 30 and 40 hours a week. So if you have a problem or want to talk privately, you can come to my office. Generally how it works is if I'm in my office, most of the time my door will be open. If the light is on and the door is closed, I'm on campus somewhere, but I may not be in my office. If the door is closed and the light is off, I'm off campus. But the phone number on the syllabus is my cell phone number. So if I'm on campus and you can't, I'm not in my office, you can call or text me. Don't abuse it. Nobody has yet, but you can call or text me and see about meeting up in my office at some point. Okay. What makes up your grade? I'm a firm believer in attendance, so 10% of your grade is the attendance. If you don't attend class, the chances of getting a decent grade are very slim. Quizzes make up another 10%. And homework assignments, 20%, and vast majority of it is going to be the 4 in-class exams. 2 tests, a midterm, and a final. All right. Homework is going to be assigned on a weekly basis. It'll be assigned, made available Tuesday or Thursday of the week, and it will be due the following Thursday. So I still working out the WebAssign stuff that goes along with the textbook, but the Thursday after it was assigned is when the assignments will be due. What should you be doing this semester? Like I said, getting a good grade is virtually impossible if you do not attend class. Attendance, is important. If you must miss family emergency, ill, whatever, let me know, and we'll get you caught up and that sort of thing. Take notes. Taking notes for the quizzes and tests is one thing, but it's also a process. In order to write notes, you have to take in the information, process it in your head, and then make your notes in a form that makes sense to you. So there's some processing going on. You're processing the information. So even if you even if you have a great memory and write your notes and throw them away on the way out the door, that's up to you. But taking the notes, it helps you process the information. And of course, ask questions. Like I said earlier, if you don't understand a concept, I'm not going to know unless you say something, whether it's in class or in my office. Either way, let me know and I'll try to explain things. Let's see here. I already went through this. Processing, organization. Organizing your notes is also an important part of taking notes. As I was telling this fellow here earlier, how you organize your notes is basically, unique to you. How do you organize your thoughts? Organizing your notes is the same way. He might organize his notes one way. She might organize their notes a different way. So keeping things organized so you can use them as reference on quizzes and tests is an important thing. I told you about the using the tablet for taking notes. Let's see here. What I will do, went through all this already. I am understanding of special circumstances. If you need accommodations for some reason, disability, sports, band. I asked about sports. Anybody in the band here? Ooh, a few of you. Okay. I understand band has obligations, and if you're on a band scholarship, that's got to take priority. I understand that. No big deal. We'll work with it. Student organizations, travel to conferences, job interviews. That's don't skip a job interview for a class. Job interviews are a one-shot deal. If you're late, even by a minute, it doesn't matter how good the interview goes, you're not getting the job. So go to job interviews, internship interviews, that sort of thing. Skip class for that. Fully understand, and we'll work with you. Any questions about how I'm going to approach this semester? I'm a fairly nice guy as far as when it comes to working with people and making sure they pass the course and get the material and move along. I've had a few of you in my classes before, so you can ask them. I'll work with you. I'm not going to leave somebody hanging out to dry if I can help it. But my office hours officially are noon to 1:30, so the hour and a half before class each Tuesday and Thursday. But like I said, Monday, Wednesday, Friday, I'm in my office most of the time anyway. So feel free to stop by. My office number is 237. That's right next door to Dr. Jackson's office upstairs. So easy to find. But like I said, my phone number is my cell phone number, so in an emergency or something like that, you can reach me or text me and that sort of thing. So we are going to look at, come on, click to exit. All right. We are going to go to Canvas. And does everybody have a laptop or something like that that they can get into? I view this as a student. Your class should look something like this on Canvas. This class. These are the first homework assignments that are going to be due. They're only like 3 to 8 questions each. They'll be due next Thursday. We'll cover those in lecture. We'll cover those in lecture today, tomorrow, and today, Thursday, and Tuesday of next week. But has everybody have access to the WebAssign stuff, the WebAssign registration and access link? This is my first time using WebAssign, so I'm not sure. Have you get the assignments and all that sort of stuff? Okay, so apparently click that link and it will take you to the Cengage site, and assignments can be completed there. I'm working on trying to integrate it with Canvas. I'm more familiar with Canvas, but the integration process has not been going smoothly for me. So we'll try to figure. We'll work that out as we go along. Yeah. Let's see here. Let's go back to the accounts and go ahead and get started with the material. Again, like I said, take notes if you can. Yes. Yes, I will be posting the PowerPoints to Canvas. They will be available after the class. I will upload those either this afternoon after I'm done with my classes, or tomorrow morning bright and early. So yes, I will be posting the slides. All right. Chapter 1 is speaking mathematically. All right. The first section is about variables. Now, we've been using variables in your classes for a while now. In computer science 1 and in your math classes you use variables. You know, a variety of different classes use variables. But we're going to look at it formally, what it actually means. Variable is thought of as a placeholder, a generic thing that when you're talking about whatever, it's just a generic placeholder, a cup, a box, that you either it has one or more values that you don't know what they are, or you want whatever you say to be equally true for all elements in a given set. Okay, so that's formally what a variable is. The first case, is there a number with the following property? Doubling it and adding 3 gives the same result as squaring it. In this sentence, you introduce a variable to replace the word it. It is kind of ambiguous. What is it? So the question becomes, is there a number x with a property such that 2x plus 3 equals x squared? Okay. Gives you a temporary name to what you're seeking so that you can perform computations with it to help discover its possible values. So there you go. The idea of a box, using a box to represent a variable, kind of makes it a little bit more intuitive. You know, what goes in the box to satisfy these conditions. A variable in a computer program is similar to a mathematical variable because it creates a location in computer memory into which values can be placed. So that's the first use of a variable, in particular in programming. It's a placeholder to hold a value that may or may not change or may have multiple values. The second use of variables, no matter this statement, no matter what number might be chosen, if it is greater than 2, then its square is greater than 4. In this case, a variable has a temporary name for whatever number, and it makes the statement general across all values that's specified in the statement. If it is greater than 2, it's a little ambiguous, but this is true with integers as well as real numbers. If the real number is greater than 2, then the square of it is greater than 4. It's generally true no matter what value you put into it, assuming it satisfies the condition given. So use the example, use variables to rewrite the following sentence more formally. Are there numbers with the property that the sum of their squares equals the square of their sum? Sure. So we would rewrite the first statement. Are there any numbers A and B with the property that A squared plus B squared equals A plus B quantity squared? So you're dealing with two numbers. So you have the two variables A and B. A and B may be equal to each other. But they can be different quantities. In the second example, given any real number, its square is non-negative. So for a real number r square is non-negative, or r is greater than or equal to 0, or r squared is greater than or equal to 0. So, that's the use of variables. Just as a placeholder for one or more quantities to make a mathematical statement either true or false, and alleviate any ambiguity that might be present in informal language. Especially dealing with computers, you don't want ambiguity because that just confuses computers. Computers don't have common sense. They work with numbers, and A plus B equals C is clear cut, no ambiguity. That's why we don't program in English, because there's so many different ways to interpret things in English. Computer languages are a subset of that, but are very unambiguous. So variables are the first step to doing that. Some important kinds of mathematical statements. Three of the most important kinds of statements in mathematics are universal, conditional, and existential statements. Now, the formal definition of those is that a universal statement is a statement that says a certain property is true for all elements in a set. So it's universally true. A conditional statement says if one thing is true, then some other thing also has to be true. So like if it's divisible by 4, then it's divisible. Then the number is divisible by 2. Something is, if one condition is true, then the other. If one thing is true, then the other thing is true as well. Given a property that may or may not be true, an existential statement says that there is at least one thing for which the property is true. Like, there is a prime number that is even. The number 2. All you have to do to show that that statement is true is give an example of one instance where the statement is true. 3 is not an even number, but it's also a prime, so you wouldn't use that as an example. But there does exist a prime number that is even. So then you have different combinations of the universal, conditional, and existential statements. The first one is the universal conditional statements. They contain some variation of the words for every, and conditional statements that contain versions of the if-then. It's both universal and conditional. Like, for every animal A, if A is a dog, then A is a mammal. Universal conditional statements can also be written in ways that make them purely universal or purely conditional. For example, if A is a dog, then A is a mammal. That's a universal. I'm sorry. That's a conditional statement. That's explicit in the statement. Or if an animal is a dog, then the animal is a mammal. The statement can also be expressed as a universally explicit. For every dog A is a mammal. So both statements are true, but how they're expressed is slightly different. But they are examples of universal conditional statements. Let's see here. Do a little in-class exercise here. Rewrite the following statement. For every real number x, if x is non-zero, then x squared is positive. So if a real number is non-zero, then its square is positive. For every non-zero real number x, then the square is positive. X squared is positive. If x is not zero, then x squared is positive. But just different ways of saying the same thing. That's how an example of how English can. There's lots of different ways of saying something. In math, they like to have it one particular way, so it's easier for them to for computers to understand and get through. Universal existential statements. A universal existential statement is a statement that is universal because its first part says that a certain property is true for all objects of a given type, and it is existential because its second part asserts the existence of something. For example, for every real number, universal statement there, has an additive inverse. There exists something. That's the existential part. Has an additive inverse applies universally to all numbers, but it also asserts that the existence of something, the additive inverse, for each real number. So it is both universal and existential combined. The nature of the additive inverse depends on the real number. So while the set of real numbers is the set of real numbers, the additive inverse is not the complete set of real numbers because the additive inverses are there's only one additive inverse for each real number. So for all real numbers have additive inverses. There exists one. So for every real number R, there is a real number S, such that S is an additive inverse for R. There is a real number. There exists a real number S that is the additive inverse. One of the most important reasons for using variables in mathematics is that it gives you the ability to refer to quantities unambiguously throughout a lengthy mathematical argument. So far, we've just been talking about one statement and that sort of thing. But when you get into more complex calculations and that sort of thing, where my brother was, when he was in college, was telling me about an equation typed out, 12-point font. The equation was like a page and a half long, one equation. Without the use of variables, it would have been horrendous and unmanageable. Whereas for a argument such as that, the manipulation of that, the use of variables is essential. You know, something that big and complex, you need the variables. Sure, right here. A universal existential statement is a statement that is universal because its first part says that a certain property is true for all objects of a given type, and it is existential because its second part asserts the existence of something. Okay. Fill in the blanks to rewrite the following statement. Every pot has a lid. All pots have lids. For every pot P, there is an L lid for that pot. For every pot, there is a lid L such that its L is pot P's lid. A little bit more wordy than what they have for the solutions, but yeah, same principle applies. But existential universal statements, kind of the reverse of the previous section. An existential universal statement is a statement that is existential because its first part asserts that a certain object exists, and is universal because its second part says that the object satisfies a certain property for all things of a certain kind. As an example, there is a positive integer that is less than or equal to every positive integer. This statement is true because the number 1 is a positive integer, and it satisfies the property of being less than or equal to every other positive integer, or every positive integer. So there exists, and then the universal statement. You can rewrite the statement in several ways, some less formal, some more formal. Again, you have the ambiguity of and the versatility of the English language here. Some positive integer is less than or equal to every positive integer. There's a positive integer m that is less than or equal to every positive integer. There's a positive integer n such that every positive integer is greater than or equal to m, and so on. There's lots of different ways to express that. Fill in the blank to rewrite the following statement in 3 different ways. There is a person in my class who is at least as old as every person in my class. Kind of confusing. Some person is at least as old as every person in the class. There is a person P in my class such that P is at least as old as everybody else. And there is a person P in my class with a property that for every person Q in my class, P is at least as old as Q. Which is true. So basically somebody in the class is going to be the oldest and is therefore at least as old as everybody in the class. So that's those statements are true. Let's see here. Everybody here is taking calculus, right? Okay, so Cal 1 at least. Some of the most important mathematical concepts, such as the definition of a limit of a sequence, can only be defined using phrases that are universal, existential, and conditional, and they require the use of all 3 phrases for every there is and if then. And you have the definition of a limit. For every positive real integer epsilon, there is an integer n that such that for every integer small n, if small n is greater than n, then that equation is true. So that's a formal definition of a limit as I understand it. How are we doing on time? 2:20? I go through things a little bit fast sometimes. I do apologize for that. But like I said, I do record the lectures, so if you need to go back over and review them, they will be made available for you the following day. Any questions so far about the? Well, I still have the slides up. Variables, universal, conditional, existential statements. Existential universal. Okay, right here. Yeah. Existential because its first part asserts that a certain object exists, and is universal because the second part says that the object satisfies a property for all things of a certain kind. So far, would you say that these concepts are what I expressed before, just mathematically formalizing common sense? Yeah. They're not difficult concepts. Sometimes they get a little abstract and, long logic statements can be hard to get your head wrapped around, but the basic concepts are simple and, like I said, for the most part, intuitive. There's a couple of rare exceptions that we'll get into a little bit later, but I've had students in the past, not in this class, but in other classes, overthink things. Just because you're mathematically formalizing things doesn't mean that they're not simple. So don't overthink things. Keep it simple. Simple works. So if you feel like you're getting overwhelmed by something, try to back off and say, okay, what are the basics? These basics are, like I said, pretty intuitive. Just a matter of learning the proper terminology. And mathematicians, they love their terminology and their symbols and their way of approaching things. So that's mainly what we're going to be having to memorize and then learn is all the symbols and the rules and the terminology. You'll find that a lot of your courses as an undergraduate are oriented toward just teaching you the terminology of the field. This is a course that is a good example of that. The terminology used by mathematicians to express logical arguments, do proofs. In a couple of lectures, I think, I was looking ahead, I'll go through the symbols that are used in this class for like a logical and. Everybody's taken digital logic, right? Digital logic? No, not yet. Okay. Well, digital logic uses certain symbols for and or and not. I know everybody's taking computer science 1 because it's a prerequisite. C++ uses certain symbols for not and or, and they're different. Math notation is, again, a different set of symbols. Same concepts, and is an and, no matter what if you're in a logic class in the philosophy department, and is still and. The concepts are the same. It's not something new. It's just expressing it in a different way. I'll put up a table at some point showing you all the different symbols that I've learned over the years for the different logical operators. But I'll do that up on the whiteboard when we get to that point. But any other questions for the afternoon? Yes. The slides? Yes, I will be posting the slides on Canvas. Yes. Any other questions? Okay. Well, I guess I'll be wrapping things up for the day.